Welcome to Ask and Learn.
Okay, we need to start this question with a balanced equation. So as you see here, I've written one out. And let's pretend that this isn't here for right now. So we're told that MgCO3 produces MgO, and we want to know what else we need to balance the equation. It's going to be some type of waste product, so the best bet is CO2. So let's check if that will balance our equation. So we have 1 Mg on this side, 1 Mg on this side, we have 1 C on this side, 1 C on this side, and then we have 3 O's. We have 1 O here and 2 O's here. So this equation is balanced. The next thing we're going to do is find the delta H of reaction and the delta S of reaction in order to find our delta G. So let's start with our delta H. We're going to use our equation, and then we're going to use our products minus reactants equation as well. And I always like to write out kind of the skeleton of what we're calculating. So we're going to have the delta H of formation of MgO plus the delta H of formation of CO2 minus the delta H of formation of MgCO3, excuse me. So again, you can look up the delta H of formations of all of these molecules online. Google, you can easily find them, but just for ease, I've written them all right here. So now we're just going to plug and chug. So we're going to plug this in here. We'll plug that in there, and then we'll plug this in there. So if you want to take a minute, pause the video, and do that little calculation. Our delta H of reaction should come out to be 11,730 joules. Perfect. That's our delta H of reaction. We're going to move on to the delta S of reaction and do the exact same thing, although now we're going to use standard entropy values. So again, we have products minus reactants. And here are the values you're going to need. Again, the standard entropies, you can look them up online. Google has a bunch of charts, so you'll be able to find them. Again, pause the video, do that calculation. Remember, you're plugging these numbers in here and that one over here. And that is going to give a delta S of 174.74 joules per Kelvin. Oh, sorry, it's a little wonky. Joules per Kelvin. Great, so now to find our delta G, we just need to use our equation here. Delta G equals delta H minus T delta S. We know that T is temperature, and we know that that is at 298. So I have my little skeleton here, and I'm just going to fill in what we already figured out. So we know that this is 1117 B00. And then we have our entropy right here, 174.74. So again, just plug and chug through that, and you should get 65200. There we go. So that is our delta G. All right, so if we want to find what the temperature is going to be to make the reaction spontaneous, we can use this same equation right here, but we're going to plug in 0 for our delta G. By doing this, we're able to find the temperature at which the reaction is going to go from spontaneous, or from non-spontaneous to spontaneous. And since we know both of these, both of our entropy, or enthalpy, delta H is our enthalpy and delta S is our entropy, we can solve for T, making sure that our delta G value is 0, and we get T equals delta H minus delta S. So you're going to plug those values in again, 117300 divided by 174.74. And you should get that at temperatures greater than 671.3 Kelvin, the reaction will be spontaneous. All right, so moving on from there, we're going to use a different equation for delta G. There are a bunch of equations for delta G. It's best just to memorize them because, as you can see, they come in handy, and we often use them a lot in chemistry. Okay, so the next part wants us to solve for the pressure of CO2. So since, let's go back to our equation up here. I think I have it written down here. Yeah, here we go. So since everything is in its solid form except CO2, we can assume that PCO2 will be the same as K. So we just have to solve for K in order to find PCO2. So again, this is purely just plug and chug. We just found G, and we know that G is 65200. And now we just need to solve this equation for K. So you're going to divide by these and then take e to the power of that answer to get rid of the natural log, and then you'll get K. If you want to pause the video, this is the value you should be getting for K, 3.71 times 10 to the negative 12. And again, since everything else in this equation is a solid, we can assume that the PCO2 is equal to 3.71 times 10 to the negative 12. Sorry, that's very messy. ATM. All right, and now we're going to do the exact same thing for this last part of the question, except we're substituting 1200K instead of 298K. So again, we're going to plug in our delta G here that we found earlier in the question, 65200. And then you're going to solve for ln K. Again, divide by these two terms, and then take e to that power in order to find K and get rid of the log. And you should get 1.45 times 10 to the negative 3, which would make the PCO2 1.45 times 10 to the negative 3 ATM.